All right, hi everybody. In this video, we're going to take a look at another example of difference of squares factoring. This time, we're going to have two binomials, okay, as those two terms there. Now, I know this is going to be difference of squares factoring because I've got the two terms, I've got subtraction in between, so I know this is set up nicely for me. I'm going to put together the parentheses for my two binomials, my binomial conjugates. I know it's a little bit harder to see with this one right here because the expressions we're dealing with are binomials, not just monomials here. So sometimes it's harder to see how this works, but I just have to be kind of really strict to the definition of the binomial conjugates. What I'm going to do is I'm going to put in the square root of 5x minus 2 squared, which is just 5x minus 2. I'll put that at the beginning in both of these two factors here. Then I'm going to create conjugates, so it's going to be subtraction and then addition. And then this will be 3x minus 4, because that is the square root of 3x minus 4 squared. I'll put that over here too. Then what I'm going to do is I'm going to drop the parentheses inside. And I got to be careful with that because the negative here is going to distribute through the binomial here, that 3x minus 4. So it'll become negative 3x plus 4. In the second one, when I drop the parentheses, that's not such a big deal because it's an addition in front. Nothing's going to change there. Now I'm going to group together the like terms. 5x minus 3x will be 2x. Negative 2 plus 4 is going to be 2. And then over here, 5x plus 3x is 8x. Negative 2 minus 4 is negative 6. And the interesting part here is I'm getting a common factor in that first factor. So I'm going to take out the 2. And then I've got a common factor of 2 here. And that's going to give me 4x minus 3. Now, because order doesn't matter with multiplication, I'm going to bring those two 2's together to get 4 times x plus 1 multiplied by 4x minus 3. Now, just to show you over here that you could do it the other way, I think what I just did there is the kind of the preferable way to do it, but you could do it the other way here. I could expand that out, and if I do, that is going to get me 25x squared minus 10x plus 4 minus, and then this is going to be 9x squared minus 12x plus 16. Okay. Now, if you're wondering where those minus 10x's are coming from or those minus 12x's are coming from, remember that when you square a binomial, when you multiply it by itself, you have to distribute each term to both of the terms in the second binomial. You have to distribute. So this is 5x minus 2 times 5x minus 2, 3x minus 4 times 3x minus 4. This is where people get this wrong all the time. They don't distribute. Okay. Now, this becomes 25x squared minus 20x plus 4 minus 9x squared. This is going to be plus 24x minus 16. Put that all together, I'm going to get 16x squared plus 4x minus 12. There is a common factor of 4 to all of those, which is exactly what I saw over here, so that's good. So it becomes 4x squared plus x minus 3. And then, now my method of choice for factoring is guessing and checking. And I would look at this and say, well, it's got to be 4x and x. And then with that 3 there, this will be minus 3 and plus 1. And yeah, that's the factoring that I'm going to get here. And they're the same in both cases there. So anyway, just to show you that it can go either way here, but this is likely the preferable method.